Okay, so today we're going to talk about independence. And the nice part about independence and conditional statements is we're pretty used to this. It's just learning the notation. So, again, let's say event A is that we get somebody who went to hospital A. And let's say event D is that they died. And let's say that we would like to know if these two events are independent. Here's what it means if two events are independent. Two events are independent if the probability of one event is the same as the probability of that event given the other event is happening. So like the probability of A given D, or if you want to do this, the probability D is equal to the probability of D given A. We're going to see what this given means in a second. So that's the basic idea behind independence. Your hope is that the probability of this event is the same as if you have this given. Okay? So we're going to see what it means to be given, and then we're going to test if these things are actually independent. So, the first statement that we had was the probability of A given D. So, if you want to figure out the probability of A given D, that means I'm looking for the probability of a hospital A given that they died. So this time I have 63 people that were in hospital A that died, and the total number of people that died was 79. So this percent would be 63 over 79. Or, if we did that on our calculator, about 80%. Okay. Let's go the other way. Let's figure out the probability of D, or the probability of that someone died if they were in hospital A. So this given would be the probability that you get someone died that was in hospital A. Scroll up. So the people that were in hospital A was this amount right here, and 63 of them died. So that probability would be 63 over 2100. Which would be about 3%. Now let's check if these probabilities are actually independent. So independent generally means the two events aren't related. But for this, we're going to see that these things are not independent. Because if I look for the probability of A, the probability of A would be 2100, because this would be the probability that you went to hospital A, over 2900. And we can see that that's close, but that's not the same. That's 72%. So, again, X-nay on this. Those events aren't independent. And then we'll do the other one, which, if it didn't work one way, the odds are it's probably not going to work the other way. So we got to find the probability that somebody died, which if we look up here, would be deaths was 79, and total was 2,900. So we go 79 over 2,000. Whoa, 900. And we get this. Well, this rounds up to 3%, but if you remember, that was exactly 3%, and this is really 2.7%. So again, we find that these events over here are not independent. So we found that these events, they aren't independent because the probability of D is not the same as the given probability. Okay. I'm going to do one more example of given, but this is the basic idea you're going to do today. You're going to see these given events, and then you're going to see if the probabilities are the same. Okay, so we're going to test if this new event is independent. So I've got all the different sequences that I kind of need, and we're going to basically see what we need to know about these things. Okay, so we're going to do the probability of B given G. So the probability of B, given that the person has taken German, so that would be 8. Because there's 8 boys given if you take German, and that would be over 11, because there's a total of 11 people taking German, which, if we do this, would be about 73%. Okay. Let's do this next one. So the probability that you took German, if you were a boy, so the people that are boys are here. The people that took German would be 8, and that would be over 20. So that would be 40%. Let's find the probability that someone is a boy. The probability that somebody is a boy would be 20 over 50, which would be 40%. And the probability that someone took German would be 11 over 50, which would be 22%. And as you can see, again, these events aren't independent because this probability is not the same as this probability. Interestingly, it's the same as this one, which is weird, but that's okay. And this one is the same as this one right here. So we can see, again, these things aren't independent because the two probabilities that we were looking for to find were not the same. So try some of these conditional statements, see if you can find whether these events are independent or not.